I'm not supposed to give this talk. It's because I will not do justice to the material. It's our student, and sessions like this are meant for the young to shine and to present their work. But there is this thing called visa. So this young man did not get his visa. So now I'm here to talk on his behalf, and I hope I will give some of the ideas that this young man is trying to develop. And being an old man, I'm too impatient, so I'll go to the results and then come back to the beginning, because just to show you here is what we're trying to achieve. So we're trying to plan crane operations, but instead of feeding the crane what it needs to do, we chose the path of running an artificial intelligence based on reinforced learning. So the crane will learn by itself what it needs to do in order to plan the path. So it starts by, like, we have different it's a process. So as you can see, before training, it just wanders around and you know, it's like a bee going all over a creation. But after training, it manages to find the load and to find the path where it needs to set it. Of course, we tell it where to set it. But this is what we're trying to achieve in essence. So now that you have seen the result, I'll take you through the different slides. Okay. In essence, what we're trying to do using this artificial intelligence concept is to improve performance and safety and other things, such as optimizing the energy consumption. Of course, many more parameters can be added, but for the time being, this is what we're looking at. Okay. In terms of objectives, the first thing that we need to do is try to develop a path planning methodology that takes into account the complexities of the site and the mobile crane kinematics. And this full automated path, so it will have to take into account the dynamic nature of a construction site, meaning that as new structures are erected, it becomes more complex as time goes by. Okay, so the idea at the end of the day is to have something that minimizes the lifting time, minimizes the energy consumption. And of course, when we say lifting complexity, it means that finding the path that does not make the crane change too many directions. So you cannot have, for instance, ups and downs all the time, because this work here is done on heavy construction. So when we lift a module, we like the module to be as low as possible and no too many changes. Okay, so that's sort of what the system is supposed to do. Okay, so this young researcher has worked with VR. So he managed to develop all these things, and it shows you. So yeah, it has the sound and all. So and it has penalties so this is what the training will do. It shows you the site, and once it reaches the end of the site, for instance, the allowed area, it stops, it has penalties, etc. So we have these different parameters that we need to play with. Okay, so in general, you know, we go through the usual thing, problem definition, data collection, objectives, etc. So there is nothing too different from all the other presentations. So that's sort of what was done. So the first, in terms of data collection and modeling. You need a model of a crane. You need a model of your payload, what you need to lift. You need a model of the rigging system, and you need a construction site, a model of the construction site. So these have to be done manually, or if you have some other system where you can grab those and run them through, then it will save you time. And the structure of this reinforcement model agent, so you need an agent that learns, and it learns by getting rewards. So every time it does something nice, it gets a reward. Every time it does something bad, it is penalized. And it's essentially a game, and it goes through this game over and over and over until it reaches a time where it has learned the complexities and the intricacies of the project and the site. So in terms of complexity of the site, so this young researcher has put some complexities like buildings, tower crane. So tower crane is not part of, it's just the complexity of the site. So just to have a realistic construction site. So these are the coordinates that he chose for his experimentation. And this is the evolution of the reward as the training goes through. So it goes millions and millions of iterations. And as you can see, in the beginning, it starts like wandering ups and downs, but with time, it converges towards the highest possible reward. So the episode length, so this is one of the hyperparameters that can be tuned to make the model train faster, okay? Otherwise, when you train, you can takes forever. So he played with this hyperparameter, and at the end of the day, we got this model who has learned its job, and it's doing it more or less decently. And with that, I think conclusions on future work. So this is what was done so far. We try to have some performance, lift complexity, which is optimized, collision avoidance, of course, and we have different things that we need to look forward to do. And with that, I thank you very much.